Good day today. Today we'll be looking at another subject, chemistry, and our topic today is calculation of pH or pOH of a solution. Now, before we look at the pH or pH of a solution, to be able to understand that the hydrogen or the hydroxyl, the hydrogen or the hydroxyl ion concentration of a solution is a measure of its acidity or alkalinity of the solution. So the hydrogen or hydroxyl ion concentration of a solution is a measure of its acidity or alkalinity of a solution. However, the concentration of hydrogen ion in a given solution is inversely proportional to the concentration of hydroxyl ion. Inversely proportional to the concentration of hydroxyl ion. This means that the hydrogen ion is inversely proportional to the hydroxide ion. So, proportional to the hydroxide ion. We can quickly write it this way: hydrogen ion is equals to Kw over hydroxide ion. And this equation can be written as hydrogen ion multiplied by hydroxide ion will be equals to Kw, where Kw is called ionic product. Of water. Ionic product of water at 25 degrees Celsius. We still have other related formula to solve this. Of course, at 25 degrees Celsius, Kw is equals to 10 raised to power minus 14. However, we can write hydrogen ion multiplied by the hydroxide or hydroxyl ion will give you 10 raised to the power minus 14. Other equations can follow from this principle, that this will be called equation 1. Equation 2 we're going to give us the pH of a solution plus the pOH of a solution is equal to 14. We call this equation 2. The other equation, before I state it, to define the pH and the pOH, the pH or the pOH of a solution is defined as the negative logarithm to base 10 of hydrogen or hydroxyl ion concentration. Hydroxyl ion concentration. Hydroxyl ion concentration. As the definition for the pH or pOH of a solution is defined as the negative logarithm to base 10 of hydroxyl or hydrogen ion to hydrogen or hydroxyl ion concentration. So to write this equation, to define this definition, it means that the pH of a solution is equal to minus log hydrogen ion base 10. Or we can write the pOH of a solution is equal to the negative logarithm to base 10 of hydroxide ion concentration. This is equation 3 and this is equation 4. So we are going to be using this equation to solve some problems that are related with the pH and pOH of a solution. For instance, example 1, we have that the hydrogen ion of a solution is the hydrogen ion hydrogen ion concentration of a solution is 5 times 10 raised to power 5 times 10 raised to power minus 4 full stop. The equation say calculate the A, the pH of the solution, calculate A, the pH of the solution, and question B said calculate the pOH of the solution. So how do we handle this question? The hydrogen ion concentration of a solution is 5 times 10 to the power minus 4. Calculate the pH and the pOH of the solution. It's very easy. Apply my formula. Apply the formula. It's going to read pH is equals to pH is equal to minus log hydrogen ion concentration to base 10. So my H plus is equal to 5 5 times 10 raised to the power minus 4. So I can now put it here. So to calculate pH now, it's going to be minus log, instead of writing the hydrogen ion concentration, I'm going to write 5 times 10 raised to the power minus 4 and put it in bracket. Remember, all to base 10. By law of logarithm, that says that log mn can be equals to log m plus log n. So I'll apply it in this calculation, because this one means times. This is m and this is n. So I can put it in the formula now. pH will be equal to minus, I'll open a bracket, log 5 plus log 10 raised to the power minus 4, all in base 10. That is the interpretation. Now there's another law, expressing this one now, there's another law of logarithm that says log m raised to power p can be written as p at the back, then log n. So I'm going to apply it on this one now, so that the 4 will now come back here, and that will give us minus 4 log 10, 10. So that will give us pH will be equals to minus, you open a bracket, and then log 5 minus 4 according to this law, then log 10 base 10. This is base 10. Of course, we know that log 10 is 1. So if we get that from the calculator, we can quickly get this result. You go to your calculator and press log 5. Log 5 is equal to 0.698. Log 5 minus log 5 is 0.6. Let me take it to 2 decimal. 3 decimal 699. That will give us 699. That is log 5. Then minus the log 10 will give us 1, and that will give us 4 times 1. And the result here is going to give negative 0.699 minus 4. So if we get 0.699 minus 4, it's going to give us a negative result, 0.699 minus 4. Answer will give me minus 3.301. That will give me pH is equals to minus, open bracket, minus 0 minus 3.310. 301. That's what I have there. Then if you multiply this together, minus times minus will give us plus. That will give us 3.301 as the answer for the pH. Then for question B, we are aware that we have that the pH plus the pOH, that is going to give us equal to 14 according to our formula number 2. So I can now put the pH I have here, which is 3.301, then plus pOH, and that will give us equal to 14. It means that making pOH subject of formula, the result is going to be equal to 14 minus 3.301. And if you subtract that, the result is going to be 14 minus 3.301. Answer will give me 10.699. That will give me 10.699. And that will be the pOH of the solution. That's right. Let's look at another example. Another example that says a solution. Let's look at another example. You can take a screenshot of this before I move on, everything here is calculation about pH or pOH. That's example number 1 we have solved. Now let me continue from this point now. Let's solve another example. Another example I have here, it said a solution has a pH of 4.5. A solution has a pH of 4.5 or 4.5, what is the hydrogen ion concentration? What is the hydrogen ion concentration? What I know is that the pH of a solution is equals to minus log hydrogen ion concentration, then base 10. This time around we are given the pH, and the pH answer is equal to 4.5. So how do we solve this? You put the 4.5 in place of pH 4.5. That will give me equal to minus log hydrogen ion concentration base 10. Then this place, before you can solve this mathematics, you need to say take logarithm of both sides, or put log. I think that is the appropriate. Put log to both sides. If you put log to both sides, before then I can quickly say that log H plus, that is hydrogen ion concentration, should be equal to minus 4.5. So this minus sign is taken to this side. So now to put log to both sides is going to give us this idea that hydrogen ion, and putting log to both sides is the same thing as saying taking the anti-log of 4.5. So hydrogen ion concentration will be equals to 10 raised to power. If you are putting log to both sides, it's going to give you 10 raised to power minus 4.5. That's how to do it. And 10 raised to power minus 4.5, somebody can write it as a 10 raised to power minus 5 times 10 raised to power 0.5. What I've just done here is that here is supposed to be it is 4.5. 4.5, the difference between 4.5 and 5 is just 0.5. 0.5 to make it 5. So that is 0.5. By the law of logarithm, if you take a log of the one base, that is, you take the base are the same, take the base and then add the power. If you add this power now by taking the base of this, you still result to 10 raised to power minus 4.5, which is the same thing. So if you use your calculator now and press, in fact, this expression means that 10 raised to power minus 5 times the square root of 10, because 10 raised to power 0.5 means 1 over 2, which is the same thing as 10 raised to power minus 5 times the square root of 10. And if we do that, the answer that is going to give us is going to be 10 raised to power minus 10 raised to power 0.5. That is square root now give us 3.162. 3.162, which means that this answer can be written as 3.16 times 10 raised to power minus 5. But if you don't want to do this, if you want to do the shortcut, what you do is that the hydrogen ion concentration, you want to do the shortcut, hydrogen ion concentration is equals to, you just press 10 raised to power minus 4 means minus 4.5 means you should write the expression like this: 1 over, you now write 10, then raised to power, you now write here 4.5. That's what you write there. You use your calculator and press this, and answer will come out. If I use my calculator and press 1, divide the result by 10 raised to power minus, sorry, there's no minus sign again because of this division sign we have done here. So that will give us 4.5. And the answer I'm going to get there, look at the answer I have there. The answer is, give me 0. I have 3 zeros here, 1, 2, 3, and then the value that, 4 zeros. And the value that I follow is 316. 316. And this 316 I just approximated to 3 significant figures. But to put that in standard form, we'll still come back to this calculation. So how do we do that? We'll move the decimal point. 1, 2, 3, 4, 5. When you get to a significant number, then you now put the decimal point. That will give me 3.16 times 10 raised to power. How many times I move? 1, 2, 3, 4, 5. That will give me raised to power minus 5. If I'm moving like this, it's 10 raised to power minus 5. If I move the decimal point this way, it should give us 10 raised to power plus 5. But this is the answer, which is the same thing with this. Thank you. We'll still continue with this calculation maybe in another time. So this is the example we can use now to illustrate a pH or pOH of a solution. In summary, the pH of a solution or pOH of a solution is the negative logarithm to base 10 of hydrogen ion concentration. And equally, in every aqueous solution, the concentration of hydrogen ion is equal to the concentration of the hydroxide ion. In fact, the pH of a solution is the measure of the acidity of that solution. Thank you.